This morning we're working on a 2017 F150. The customer's concern is there is a growling, grinding noise when he is driving down the road. Changes a bit when he moves back and forth with the wheel. Sounds like a wheel bearing, but I hear it on both sides depending on how I drive. So we're gonna put on the electronic ears with our ATS scope, and we're gonna try and figure out where that noise is coming from. So this is our intelligent vibration analyzer from ATS. It works with our ATS scope, and what we do is we use these clamps with speakers on them, little microphone speakers, and we'll clamp those on the different corners and then go drive it, and we'll get a visual representation of the noise that it's making. So I'll show you how I hook it up, and then show you how we drive it, and hopefully we'll be able to isolate which corner or both corners are making noise. Alright, so we're going to put on red on the right, red for right, and I think I'm just going to clamp it onto, let's see here, we need to clamp it someplace where it won't get in the way if we drive. And this just plugs in here. So I made some little clamps holders here on my 3D printer, put a little magnet on them so they hold really nice. And they'll kind of hold it off the ground to protect our cable here. Since this is a Ford and aluminum body, we're not going to be able to hook it to the door because all this is aluminum. Not magnet friendly. So the rest of this cable will go up through the window and attach to our scope. So I will take the slack up on this. Now, do the same on the yellow. Okay, let me take you around here and I'll show you how I did those clamps. So you can see the sensor there. Cable runs up here, clamp, 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 and then I'll run that up through the window. And on the driver's side, we have the sensor there, and then the clamp, 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 and I'll run up through the window up there. Alright, so we've got the IVA all hooked up. Here's our cables that were down at the sensors on the wheels. This is our module box that basically speaks to the lab scope. It has a connection to the ALDL underneath the steering wheel. So it gets speed data and vehicle data. All right, and here is our screen. So we've got it set up for, it's a four-wheel drive vehicle. We've got 2 microphones, and we are on wheel suspension. So it's already got the vehicle info on here because we are hooked up to the ALDL. We're not worried about gear ratio because I'm not after a driving vibration that I would need to isolate, whether it's a differential or a transfer case or a wheel speed. This is basically a noise that we're after. So we're going to hit start testing, and warning saying drive it on smooth roads and don't pay attention too much to your scope when you're driving. Alright, so we don't need sensor 3 and 4, so we can get those off there. We've got 1 and 2 in there, and you're not seeing 2 just because they're all on the same line. So if we turned off the yellow, you'd see red there. So they're both there. What we're going to see when we go drive this thing is you're going to hopefully see one of those have much more amplitude than the other. So let's get this thing rolling. Hopefully my camera doesn't fall over. So as you can see on this is different frequencies that it's seeing. And you can see the high yellow spikes over here. What you're seeing there is just that's the frequency that that bearing is making noise at. So it's definitely on the yellow side. If we change back to live graphing, you can see how high that frequency is on that yellow graph. If we turn off yellow and just have red, it's much less amplitude on there. Alright, so I'm going to take off on a road here, fairly smooth road, except for that bump there. And then I'm going to rock the steering wheel back and forth. What that does is it loads and unloads the different sides of the bearing. We'll see if we get through this intersection. Okay, so now I'm going to load and unload the steering, and let's see what happens with the graphs. So alright, so that's clearly the yellow channel making noise there. Let's turn off the yellow channel and then load this back and forth like we did. See, we don't get the bulk of that noise like we did on the yellow channel. Let's turn that back on. Now when we load that back and forth, so what I'm doing is I'm rocking the steering wheel left to right, as we're driving, and you can see that pulsation on the yellow channel. Yellow channel is on the left side, so it's our driver's side that's doing making the bulk of our noise. Alright, so got back from the road test. Obviously that left side channel is showing way more noise than the right side channel. So I shook this front end down before we road tested, and it was tight. You couldn't hear it when you were spinning the wheel, but you can't spin the wheel fast enough as you can on the road, and I can't load that bearing enough to really show any noise on that bearing. So pretty obvious on the lab scope. The power of that IVA machine, or IVA tester, is pretty incredible. Kind of takes the guesswork out of it. Makes it a for sure diagnosis. So we're going to write this thing up for a left front wheel bearing. And I want to tell you, the customer just got tires, so it's not a tire issue, because that can make the same kind of noise, but he just got tires, and the noise was still there after he got tires. So it's not a tire issue. It is definitely a bearing. So we're going to write this thing up for a faulty left front bearing. Once I'm done with that bearing, I will hook all this back up, and we'll take it out for a drive, and you can see what a good bearing looks like on the scope. All right, so we sold that the left front wheel bearing. We got the part. I'm gonna show you how I replace this thing. We'll put it all back together, and then I'm gonna take the vehicle out for another road test, and I'll show you what a good sensor looks like. We also left the door open with the customer so that just in case we possibly may need the right side, because there was some noise on that right side, but obviously this was the bulk of the noise. But with a brand new bearing on this, we'll be able to compare the right side with a brand new bearing. I don't suspect that's our problem, but there was some noise on that side, so we'll compare that and then go from there. But like I say, we left it open with the customer. He knows that it may need a right side, but the left side is the bulk of his noise. So follow along. We'll get this thing pulled off of there and replaced and put her back together. So I've got it broken down this far here. The camera didn't record that first part, so I just noticed that it wasn't recording. So basically I just took the brakes off. I unplugged the harness for the ABS sensor. Tie rod end is off. Basic stuff. Nothing that you need a recording to show you how it's done. So now we got the 4 bolts that hold the actual hub on. And just like that. All right, torque on these hub bolts is 129 foot-pounds. What's up?
I'm gonna burn this again.
Okay, so we got the bearing all done. Everything's torqued. We're going to road test this thing again. I've got it hooked up the exact same way. So we're going to be watching the yellow and red traces on here and seeing if we got a little less amplitude now. All right, you can see that the yellow is much less amplitude as it was, and you can also kind of see that the red amplitude is more now. Those flashes that you see there, those are me hitting potholes or bumps in the road. Those are going to pick it up as noise. So but you can see that red trace behind the yellow. That's the not new bearing versus the yellow one, which is the new bearing. So the red one is not making noise, so we're not going to sell it to them. Don't hear any noise out of that at all, but there's definitely more noise there than a new one. Yeah, see those bumps are just the potholes of the uneven road. The reds have got a little bit more amplitude, but it's not making noise, so we're not going to sell him that bearing. If he can put that off a year or 6 months, then that's what we'll do. But you can see the sensitivity of this machine with the when we hit a pothole. But that is a conclusive fix on this one. So there's the pattern for a fairly smooth road, and good bearings. The right one shows a little bit of noise, but not enough that we can actually hear it. So we'll let that one go until it gets worse. Thanks for watching.